Welcome to the next episode of Blind75, which is Insert Interval. Let's take a look at the problem. You are given an array of non-overlapping intervals where intervals of I is equal to start and end represent the start and the end of the ith interval, and intervals is sorted in ascending order by start. You are also given an new interval, start and end, that represents the start and end of another interval. Insert new interval to interval such that intervals is still sorted in ascending order by start and interval still does not have any overlapping intervals. Return intervals after the insertion. We have given constraints like the intervals can be empty and the length can reach up to 10 to the power 4, and each of the entry in the intervals is of length 2, and start and the end values can vary from 0 to 10 to the power 5, both inclusive. Intervals is sorted by start in ascending order. So if you remember, in the merge intervals we did sort by the start in order to merge it. So in this case this is already sorted, so we don't need to do the sorting here. And the new interval length is 2, and the value the value can range from 0 up to 10 to the power 5, both inclusive. Okay, so if you take a look at the example, what we need to do is we are given a list of intervals 1 to 3 and 6 to 9, and the new interval is given 2 to 5. 2 to 5 is overlapping in this particular interval, so we merge it and we say 1 to 5 and 6 to 9. If we don't need to merge it, that means if it is not overlapping, we need to insert into the output and return. So if you take a look at the next example, 1 to 2, 3 to 5, 6 to 7, 8 to 10, 12 to 16. The new interval is 4 to 8. That means it would come here in these two intervals. So what we will do is 1 to 2, and this one we will merge 3 to 10, because this would become 3 to 8, and again there is 8 to 10, so we merge it as 3 to 10, then 12 to 16. So this is how the overlapping becomes. Let's see how we would solve this. So I have written the example given here. So as I explained, we can do a linear search to find where this start would fit in. So if you search here, 3 is greater than 2. That means this and this is overlapping. So we find the values in the result like 1 to 3 and 2 to 5. So it becomes 1 to 5, and we continue with the rest of the interval. So this is exactly what we are going to do. So in the first step, what we would do is we would iterate from the start of the interval until we find a interval which is less than this particular value where it is overlapping, right? Overlapping, or it can be inserted, and we do that iteration, and once that is done we find the new interval. Like if we need to merge it, what will be the new interval? It will be 1 and 5, right? So we compute that using the values, right? So there could be cases that we have multiple uh, indexes to, or multiple intervals to merge, so we find the maximum value there, then we append that, and then we so one is finding the place where the new interval belongs. That is the first logic. Second, finding the new interval, whether it is overlapping or not, we find the new interval, then adding it, and once that is done, the rest of the values also need to be updated. So we do that as a third uh, logic. So let's see how we can implement it. Okay, so let's see. So what we have is merge. So this is going to be the result. N is equal to len of intervals, and I will start from 0, and what we'll do is while I less than n and intervals of I of 1 is less than new interval of 0. new interval of 0. We'll keep updating to merge dot append of intervals of I. Then we'll keep updating. Okay, so what we do is we'll do the first process where we keep on appending to the result until we find a place where we can insert this new interval. So that is like a pre-processing. So we did that. So when we break out of this, that means we have found the position where we need to insert this, right? So we need to now find the new interval with that merged value. So what we'll do is while I less than n and intervals of I of 0, the start is less than or equal to new interval of 1. We find the new interval, right? So we'll update new interval of 0 is equal to minimum of intervals of I comma 0 and new interval of 0. What is the end value? End value will be the maximum of the new interval. So max of intervals of I comma 1 comma new interval of 1. Then we will keep update. So if we need to say merge multiple, so we that happens in this while loop. So once that is once we are out of this loop, we'll get the new interval modified in such a way that we merge the intermediate overlapping intervals. It can be multiple. So what we do is we'll append it to the merged value. Okay. So what that is done, we might have some more elements in the list, right? So we need to add that. So one while I less than n merge dot append of intervals of I plus 1 and we return merge. Yeah, so we did it in 3 parts. First, add the intervals. Those are not overlapping and is less than the new interval. So we add it. So once we find that out, we iterate and figure out the new interval such that we do the overlapping if required. So after this while loop, we got the new intervals. We add it. And we might have more entries after the new interval. In that case, we add the rest of the intervals to the result array and then we return it. So that's it. Let's try running. Yeah, let's try submitting it. Okay, so what is the time complexity here? So we do it, the while loop runs order of n times. So the time complexity is order of n, and there is no, the space complexity is the worst case, the space complexity is order of n because we are returning it in a new array. Yeah, so that is that. Can we improve this further? So we know for a fact that the intervals are sorted by what do you say? Sorted by the start name, and the values are also sorted, right? So if you remember, what can be used for to find an element in a sorted array? So we can use binary search. So there is another solution using binary search. So let's see. So what we are going to do is we will find the index where this start element would fit in. We will find the index where the end element would fit in, and then we'll merge that particular piece. So if there are multiple, then we'll merge or replace that particular number of intervals with a new interval set. So this searching for position to insert 2 would take order of log n because it's binary search, and to find for the value to fit this 5 in, that will take again another order of log n, and then we'll replace. So the complexity would become approximately order of log n, which is better than order of n. So this is the optimized solution. Let's see how we could code this, right? So I'll use a built-in binary search in Python, so which is called as bisect. What does bisect do? Bisect uses binary search to find a position to to insert a particular element. So what we are trying to do is instead of using a linear search to find the suitable position for the new interval, we are using binary search here. We need to find the first interval in the list intervals having a start value greater than the start value of new interval. So we would find an interval greater than the value of start and lesser than the end value. So that's it. Then we kind of replace it, right? So let's see. Start comma end is equal to new interval. So we are taking it in two variables, where start is the start of the new interval and is the end of the new interval. So we are finding the left side ending ending value here, but this would fit in, the start would fit in. So left end is going to be bisect left, and what should be fine in the intervals, and true key is equal to lambda interval, start is less than or equal to intervals of 1. The start value is less than or equal to intervals of 1. So we find that left side end and right side start would be similar, bisect left of intervals, true key is lambda interval, end is less than intervals of 0, end is less than the starting of the particular interval. So we find that out. So we got the left end and the right start. So if left value is less than len of intervals, that means it lies in between, we would modify the start value. Start is going to be minimum of start, whatever the start value is already here, and intervals of the left end and 0. So here the left end would be 0. Okay, so we are considering the start value as left, the start of this particular left end. If 0 less than or equal to right start minus 1, we would change the end value, which is going to be maximum of the current end value and intervals of right start of 1. Okay, so okay, so the end will be 5, because we are trying to do the maximum of 3 comma 5, so we get 5. And what we do is we just replace that many values in the intervals. So we are doing an in place change. So intervals of left and to right start would be start comma end, then we return interval. So we just change that, right? So let's try run it. Hold on. Okay, so what is wrong? Oh, it is interval of 1. Okay, hold on. So we got start equal to, did we miss anything? Start is less than or equal to interval of 1, right? Start is and less than interval of 0. Oh, okay, so we need to do -1. Yeah, so we are finding the rightmost start element, right? So we have to change the one. So the right is going to be this one, so we have to when you, okay, so the if I take an example, left end will return 0, right start will return 1. So what we have to find is right start -1, which is 3, right? So that's what we need to do. Interval of left. Okay, let's yeah, so let's try submitting it. Yeah, so so we found this, and the time complexity is order of log. So since we do an in place changing, we don't what is it, we don't create a new array to return. So the space complexity is order of 1, which is constant. The time complexity is order of log n to find the left end, order of log n to find the right end. So we can say approximately it is order of log n. So that's it, guys. That's the end of the 18th problem, which is insert interval. Thank you so much for watching the video. Please feel free to comment or give me any feedback if you didn't understand anything, or if you want me to concentrate on something. Maybe I'm doing it wrong. I'm also new to this, so any feedbacks are welcome. Please let me know in the comments. Don't forget to hit like, comment and subscribe. Also, please don't forget to click on the bell icon so that you can get notified when I upload a new video. So that's the end of this video. Thank you so much for watching. Let's see again with another problem from Blind75. Thank you. Bye bye.